Hello students, from the subject of engineering thermodynamics, today's topic is numerical on heat engine. Before proceeding, let us first recapitalize what is a heat engine. A heat engine is a cyclic device which converts part of heat received QH from a heat source at a temperature TH into work W net and rejects remaining heat QL to a heat sink at a temperature TL. After that, we can summarize the formula required for calculation of numerical based on heat engine. The formulae are: number 1, energy balance for a heat engine is given by QH minus QL is equal to net work produced. Second, thermal efficiency of a heat engine is 1 minus QL upon QH, where QL is the heat rejected to the sink and QH is the heat supplied to the heat engine. Thermal efficiency of a Carnot engine which works on Carnot cycle is given as 1 minus ratio of TL minus TH, where TH is the temperature of heat supplied and TL is the temperature of heat sink. And also we know that there is a Carnot theorem which says that efficiency of a Carnot engine is always greater than efficiency of actual heat engine. Having summarized the formulae, let us start with actual numerical on heat engine. Let us start with the first numerical. A heat engine develops 21 kJ of work while it receives 85 kJ of heat from a source. Evaluate the thermal efficiency of and the heat rejected by the heat engine. The steps to solve any numerical are: number 1, read the numerical carefully, decide the topic on which the numerical is best. Then, number 2, draw a sketch of the system, a simple line sketch. Here, in this case, the system is a heat engine. Number 3, identify given data and write in symbolic form. For example, here QH is 85 kJ, net work developed is given as 21 kJ. We have to find out QL, heat rejected, and thermal efficiency of the heat engine. Here, while writing the data, be consistent with the units. For example, we can find that heat supplied and net work both are in kilojoule. Next step is you have to write down the relevant formulae for the numerical. Here the formulae are: number 1, QH minus QL is equal to W net, or rearranging it, QL is equal to QH minus W net. Second formula is thermal efficiency of engine is equal to 1 minus QL by QH. Substitute input values and solve the equations. Solving these equations, we get QL is equal to 64 kJ and efficiency is 0.2471. But we generally express efficiency as percentage, so it becomes 24.71%. Student, this is not the end of the numerical. We have to check the units, that QH, QL and W net have the same unit of kilojoule, plus efficiency is expressed in percentage. After that, you have to logically check your answers. Number 1, is QL less than QH? Yes. Secondly, is that engine efficiency less than 100%? Yes. If both answers are yes, then it is high probability that your answers are correct. This is the end of solution for numerical 1. Illustrating numerical number 2 for heat engine. In a steam power plant, turbine develops 100 kJ of work while heat supplied in boiler is 300 kJ. The feed pump consumes 500 joule of work Find the heat rejected at condenser and thermal efficiency of plant. Read the numerical carefully. Draw a neat sketch of a system. Here in this case it is a heat engine. Identify given data and write in symbolic form. QH heat supplied 300 kJ, turbine work 100 kJ, pump work 500 Joule. Here you will note that the pump work unit is Joule, so there is inconsistency with the units. You have to convert that Joule into kilojoule, so pump work becomes 0.5 kilojoule. Now we can proceed further. You will now write down the relevant formulae for solution of the numerical. W net is equal to W turbine minus W pump. QH minus QL is equal to W net, or rearranging QL is equal to QH minus W net. Efficiency of heat engine 1 minus QL upon QH. Next, you substitute the input values and solve the equations. Solution of first equation gives net work is 99.5 kilojoule. If you solve for the next equation, you will get QL as 200.5 kilojoule. This is our first required answer. Third equation gives efficiency as 0.33167. In percentage, it turns out to be 33.167. These are our required three answers. Now here again we will check that consistency of units. All the answers are in same unit, that is kilojoule. And finally, efficiency is less than 100%. This is our logical check for this numerical, and it confirms that our values or answers are well within the range. These are the two examples for illustration of heat engines. Now students